Welcome to the new stuff training for feet 12364, encrypted replication traffic. So no surprise here, based on its name. As you can tell, we are essentially encrypting all replication traffic for virtual machines and for volume groups between source and target Prism element clusters. As far as prereqs, so AOS 6.1 is the version required. No licensing, no additional licensing, I should say. All hypervisors are supported on all platforms. There's nothing for Sizer to support here. And then availability will be when 6.1 is GA. So why are we delivering this feature? First and foremost, this is a table stakes feature that we are delivering to help bolster our security story as well as stay competitive. Second, this is also being delivered for our customers who run business critical apps that host sensitive data so they can stay compliant within their own orgs. And then lastly, we are delivering this to be essentially an easy to use encryption feature. So initially it's going to be enabled and disabled with a script and a command line interface. But again, it's designed to be easy to use, hypervisor agnostic, and use the system keys built in. So you're not having to mess around with encryption keys and things like that. So in order to enable encryption between two Prism element clusters, you're going to SSH into both Prism element clusters. And then once there, you're going to CD into /home/Nutanix/bin. And once you're there, you're going to issue a command. So it'll be Python space on-wire encryption tool. So you're going to essentially run this this Python script with the --leap --enable space the remote cluster VIP that you're going to establish the handshake with. And then so once you do this on one side, you're also going to do this on the other side. And after that, you're going to restart Cerebro and Stargate services on both Prism element clusters, and listed are the commands to do that. So as far as POCing the encryption feature, essentially what you'll do is complete the steps in the previous slides to enable encryption between a source and target Prism element cluster. And then you'll create a protection policy with a schedule, and then add a virtual machine to that, which will start replication to the target Prism element cluster. And then once replication is proceeding, go to the 2020 page on the CVM and scroll down to the remote site additional info, and then scroll to the right where you'll see on-wire encryption enabled. You're looking for equals true for the remote site setup that you have. Welcome to the new stuff training on feet 11940, improved VSS provider. The improved VSS provider lends some enhancements that helps round out our backup story a little bit as it pertains to our backup partners. First, we now support application-aware full and incremental backups. We also have the ability to include or exclude specific providers, which basically means that backup software partners can now specify which provider to use based on a given Microsoft application. And lastly, we have the ability to generate and store VSS metadata, which aids in the ability to create application-aware backups and restores, as well as complete them more quickly. As for the prereqs, this feature is a part of AOS 6.1. There is no additional licensing needed. It's supported on all hypervisors on all platforms. This feature doesn't require updates to Sizer and will be shipping once 6.1 is GA'd. So as far as the value prop, it's really around a few key things. Keeping in mind that this is a quality of life improvement, this will provide the ability to now do incremental backups instead of just fulls. This, along with storing the VSS metadata, will help reduce backup and restore times. So here we have the first few steps in taking a VSS snapshot. So after that, the VSS provider will then query for a snapshot status. Snapshot status is then returned to the VSS provider. And then the snapshot's finished and the VSS metadata is stored in the Insights database. Welcome to the new stuff training on feet 12395, in-place entity restore with recovery points and leap for AHV. This feature allows the use of VM recovery points to complete an in-place restore as opposed to a clone restore. By doing it this way, we are retaining the unique identifiers for the virtual machine, as opposed to doing it the previous way of cloning, where essentially a new MAC address, a new VM UUID is created, and categories are not kept. As far as prerequisites, AOS 6.1 and PC 2021.12 are the minimum required versions. There is no additional licensing required for this. Currently, AHV is the only supported hypervisor. It is supported on all platforms. Sizer support, there is no change needed for this feature, and this feature will ship when 6.1 is GA. The value proposition for this feature is really around customers can have services that are tied to some sort of unique identifier, whether it's the MAC address or the VM UUID that's a part of either a workflow or something else. So this feature becomes really important for them, where they can essentially retain those unique identifiers as a part of the restore process. Here's a screenshot for the VM revert workflow. So whether you're using out-of-band snapshots or scheduled snapshots as a part of a protection policy, you can go into recovery points inside of Prism Central and find the recovery point for the virtual machine that you want, and then click revert. And then essentially what will happen is the virtual machine will be reverted back to that point in a powered off state. And from there, you can power on your virtual machine. So as far as things to consider, there's no changes needed for sizing or the methodology that you use to size. This process is supported inside of Prism Central for vDisks only. Volume groups are supported, but with API only. Lastly, this is an AHV only feature today. As far as how to POC, essentially what you'll do is create a virtual machine with 2 vDisks. Once you do that, SSH into a CVM and bring up a CLI, and then type vm.get space VM name. And what you're looking for here at the bottom is the UUID field, as well as the MAC underscore ADDR MAC address field. And then copy and paste those somewhere else for later. At this point, take an out-of-band snapshot. And then once that's done and complete, delete one of the vDisks and then revert back to the previous recovery point that you just took. And you'll notice that it restores both vDisks to the virtual machine. And then once that's done, go ahead and log into the CVM again and use a CLI to do a vm.get space VM name and verify that the UUID and the MAC address are the same as before. So under the covers, we're essentially taking a snapshot, and when we revert back, we're actually deleting the initial virtual machine, recreating it with the new snapshot that you've taken, and then we're essentially placing the existing attributes over top so that it retains the UUID, the MAC address, and some other unique identifiers.